So we'll center our discussion on complex numbers. And sets and binary operation. Okay, so as usual, by using questions. So question 1. So we have an operation star only set of real numbers. Is defined by A star B is equal to AB minus 2A squared. Then part 1. So is star a binary operation? So is star a binary operation? On R? That's the first question. The second question is star commutative? And then the third one is where we're asked to compute two star 0 star minus 2 and 2 star 0 star minus 2. Reduce if R is associative. Okay. So we have these three questions attached to that operation there. So the first one is, are we able to check if star is a binary operation on R? If not, we need to step. And then secondly, is it commutative? Third, we compute those two and then deduce if it's associative. So now let's see part 1. Is star a binary operation on R? How do you decide? How do you respond? So the idea is if star is a binary operation on R, then, so if star is binary on R, then for every A, B in R, A star B should also be in R. You see? If star is binary on R, then for every A, B in R, A star B should also be in R. So if we get 2, 3 from R, after you work out the 2 star 3, it should also be a number in R. Now, since R is a set of real numbers, you will agree that when you multiply 2 real numbers, that is A, B, we still get a real number. And then we subtract 2 multiplied by A, it will still be another real number. The difference is real, and then you square it, it's still a real number. So for such, you just say, in response, you say star is binary on R. So star is binary on R since for any A, B in R, A star B, which is equal to AB minus 2A squared is in R. So you just write that. There's no working, like you start working out things. The only time you should be, for real numbers, when you see R, the only time it fails to be binary is when there's a square root. Because you know, the square root of a negative number is a complex number. So complex are not real numbers. So real numbers only fail on that situation when there's a root. If there's no root, all real operations will be binary, unless there's a square root. Okay? The second one, is it commutative? There, we just want to check if A star B is equal to B star A. So now, A star B is there. What about B star A? So B star A means, instead of multiplying AB, you multiply as BA minus, instead of saying 2A, since the place of A has now been taken by B, so now multiply by 2 by B, and still have it squared. The fact that this number is not equal to that number makes it so easy for us to just say, but this is not equal to AB minus 2A squared, which is A star B. They are not equal because we are subtracting, because this number and this number, they are equal. AB and BA are equal. but 2B and 2A are not equal. So we don't expect the difference to be equal even after squaring. So then we say star is not commutative. Okay. So star is not commutative based on that comparison there. So we want them to be equal. So if they fail to be equal, then there's no commutativity. The third one, compute 2 star 0. So we do 2 star 0 first. So want to do 2 star 0 star negative 2. So we start with 2 star 0 first. Do you know the brackets? So where there is A, we have 2 now. Times 0 minus 2 times A, and A is 2. Then we square it. So we're getting 0, this is 0, minus 4 squared, which is equal to positive 16. This number, we now place it where there is 2 star 0. So we now have 2, we now have 16 star negative 2, which is, you open the brackets, multiply A times B, that will be 16 times minus 2, and then minus 2 minus 2 times what? Times A, and A is 16. And then we square. So we're getting minus 32 minus 32, which is going to be minus 64 squared. At least we know it will be positive 64 squared, even if we don't write the actual value. Then now, we have found this value is for 2 star 0 star negative 2. Now we want to do 2. So now I want to do, we'll start with 0 star negative 2. So we say 0 star negative 2. So this is like A, this is B. So it will be 0 times minus 2 times 0. Then we square. So that will be 0, 0 squared, we get 0. Okay? So now where there is, so the 2 maintained. So this 2 star 0. But look, here we found 2 star 0. So we just take 2 star 0 is 16. So that 16 is the one that we have now as 2 star 0 star minus 2. So now we are saying, oh, star is not associative. Why? because A star B star C is not equal to A it's not equal to A star B star C. The two are not equal. They are supposed to be equal. That's how you get to check. Any questions? So binary, I think we'll do quite a good number of questions on binary because for some reasons, it doesn't come out so clear in most time. But maybe if we can do some good number of questions, not one day, on different days. Maybe this day you pick what it means to be binary, that day you pick commutativity, that day you pick associativity, then you have all the pieces together. Otherwise, the concept is not so deep, it's something that is light. You just need to get used to say, okay, this is star is not a plus, it's not a minus, it's not a multiplication. It can be any of these. It can mean multiply, then subtract, then divide. Okay, it gets a combination of the operations that we have. Like here, it was saying you first multiply A times B. You also multiply A times 2, and then you subtract. After that, you square. It was saying so many things. And what's key in binary is when you say A star B, it's about the position. This is box 1. You can even do this star box 2. Okay. So whatever sits in those boxes, you will be told where to put them on the line. So you understand them as seats. So whoever sits here is like the seat of the president. Okay, so whoever occupies that seat becomes the chief commander of all the armed forces, regardless of their name. So that's how, when you say A star B, if we switch them, become B star A, they play different roles. That's how you should always be thinking about the binary plan. Okay. Another question. Question 2. Express as a single factor. Or in the form A plus B and C. So maybe to avoid the confusion, let's remove this part. Let's say let's write it like this. I will understand it better. Express in the form A plus B root C. So what are we given? We are given 2 minus the root of 75 plus 3 over root 5 minus 4. So you see, so many things have been mentioned here. We want to express in the form A plus B root C. And then we have 2 minus the root of 75 plus 3 over root 5 minus 4. How do you do that? So first, we work out this. Okay. That is 75. But 75 can be written as 25 times what? Times 3. But if I say 25 times 3, we can again separate it to be root 25 times root 3. That is 5 root 3. So now we have 2 minus 5 root 3 plus 3 over root 5 minus 4. So they are different. There's root 3, there's root 5. So our main job is to make sure that in the denominator, there's no root. So we'll have 2 minus 5 root 3 plus 3. You multiply up by root 5 plus 4. We're now rationalizing this part. Here, root 5 minus 4 and root 5 plus 4. So we'll have 2 minus 5 root 3 plus 3 by root 5 plus 12 over, what is root 5 times root 5? We get 5. And then we know that this one times that one, and this times that, they will cancel. So we just do minus 4 times 4, we get minus 16. So we write this as 2 minus 5 root 3 plus 12 over 5 minus 16 minus 11. And then the same minus, or we put plus first, 3 root 5 over minus 11. So we know we can put this and this one together. So we have 11 down. Then this is the 1 there. So 1 into 11, we get 11. 11 by 2, we have minus 22. Then we have plus 22, sorry. And then minus 12. So that minus remained with 12. So we took a positive 11 there. And then minus 5 root 3 plus 3 root 5 over minus 11. So this is 10 over 11 minus 5 root 3 plus 3 root 5 over minus 11. So we leave it like that because even if we put this together, the fact that the roots are different, we cannot put that whole thing in one place. So just leave it like that. So our job here has just been to rationalize and make sure that we get rid of any root in the denominator. And then we opened up the 75 to the simplest form of it, which is 5 times 3. So you don't get bothered to say, no, what do I do? I have 2 roots, I need to cancel one. You don't necessarily need to cancel one. Just get to rationalize that part which is rationalizable, and then you are done. You've done your work. Is that okay? Okay, so well, we need clarity, please feel free to ask. Question 3. Simplify. Three over I plus 4I over 7 minus I minus I to the power 17 plus the root of minus 25. So you see, this is a complex number. And there are so many things in one question. Whenever you're taught to simplify a complex number, what you need to do is first, you must be able to get rid of any I in the denominator. That's the first thing you do. And then after that, maybe you can add whenever there will be i's, you put them together. So we have the real parts together and the imaginary parts together. So we'll start with the first one. 3, we multiply by I and divide I multiplied by I. Okay. So you do that, and then plus 4I, we multiply again by 7 plus I and divide. 7 minus I multiplied by 7 plus I. So there we are going to get it. Not bad. Okay. Then what about I to the power 17? I power
Excuse
17.
me, sir.
Hello.
Can you come again on 3 over I? How you did the 3 times I over I times I?
So there we want to get rid of I from the denominator. So we've multiplied up by I and down by I. So we could have used the negative if we wanted, but then it's still the same thing. We can use even a positive because we only have a single I down there. It's not a sum.
Okay, sir.
So now let's do with I to the power 17. I power 17 can actually be written as I power 16 plus 1. And not plus I, but plus 1. Plus 1. We're doing that because we know that now this can be written as I power 16 multiplied by I power 1. But I power 16 is also I, since we can divide 16 by 2, so do I squared by 8 times I. So we have minus 1 to the power 8 times I. Now negative 1 power 8, that's positive. So we just remain with positive I. So I17, since there's the minus is still there, and this whole thing has become I now. And then we also know that I is equal to the root of negative 1. So if we write the root of minus 25 as the root of negative 1 times the root of 25, then we'll have root of 25 is 5, and the root of negative 1 is I. That whole part is going to be 5I. So now we can come back and do the multiplication. So we have 3I over I times I, that's negative 1. And then plus 4I times 7, we get 28I. And then 4I times I, we get minus 4. And then divide by 7 times 7, that's 49. And then 7 times I, we know that would be 7I minus 7I, that's 0. Then I times I, that's positive 1. Now positive 1 times the minus that is there. So we get a positive 1. Okay, so I times I is negative. Then times the negative that is present on the I. So we get a positive 1. And then here we can add now. So we'll have a plus 4I. So from there, we now get this to be minus 3I. So minus 3I plus 4I will remain with 1I. And then plus, so let's separate here, 28I over 50 minus 4 over 50. Like that. Which is now equal to, so we can have simplifications here. 28. Okay, let's start by doing this. Let's put 50 down. We'll simplify it like that. So we get 50I here, 50I plus 28I. Since here we have put over 1. And then minus 4 over 50. And for now, let's leave it like that. We'll get the equation. So 50 plus 28, that's 78. I over 50. And then minus 4 over 50. So we divide 2 into 78. That's 36. That's, what's it? It's 39. 39 I over 25. 2 into 50 is 25. And then minus 2 into 4 is 2. And 2 into 50 is 25. So we can leave our answer in this form. So worked out everything. Okay. So I've just done one example, one question per concept. So done one question on binary, one question on complex, one question on SAT. Okay, so I've tried to be a bit slow until you guys write the chemistry, because I want to be giving you work to do every after class. So now what I've discovered is that even if I give you work here, not all of you will do it because of the chemistry test that's there. Maybe just try to be a bit slow, and then do that will happen set it with all the tests. That's at least the set of chemistry when they do normal way. So we can be given tasks now. And I'm trying to do them. Okay, so we end here.